In the following demonstration, Freeform Modeling Plus will be used to model a custom skull patch implant. CT data of a patient's skull was converted into an STL file. That STL file can be imported into Freeform Modeling Plus and converted into virtual clay. Once virtual clay, the model, in this case the scanned skull, can be felt with the Phantom desktop device. Curves are then drawn on the surface of the model, offset from the beginning of the defect area. These curves will be the boundary for the beginning of our patch. There are 50 fit control points established to each one of these curves, and that determines the precise fit of those curves to the surface of the clay. We can use the shape patch command to establish cross-sections for this simple NURB surface. Let's establish one in the U direction and one in the V direction. These cross-sections have edit points assigned to them. Let's lower the number of edit points to 3, therefore simplifying the number of edit points that need to be moved to describe the complex curvature of this skull patch. Rotate the view often, haptically grabbing to the center crosshair, as well as the tangency handles on the ends of each spline. So rotate from the side to the top to the front. There's a haptic snap when you reach tangency, as well as that purple dot. That's a visual cue that you're tangent with the surrounding area of geometry. And that is the reason that the curves were drawn offset from the beginning of the defect area. We want to be tangent to the parts of the skull that are not affected by the wound. Once a proper curvature has been established, we can apply this shape patch and then thicken the patch into a plug. We can define the thickness as well as the clay coarseness for this plug. Before we thicken it, the NURB surface has no thickness. It's described only by the boundaries as well as the cross-section curves. We need it to be thickened into virtual clay so that we can tug and push and pull on the patch to make sure that the geometry is perfect with the defect area. We'll hide those curves that were the boundary for the surface, and that surface is no longer evident in our object list. Right now we just have a voxel volume at the moment, a virtual clay volume. So I'm going around the border and tugging in the clay plug so that it meets up with the beginning of the defect area. This is another reason why the patch was created hanging over the beginning of the defect area rather than starting directly at the top of that hill that goes down into the wound. We wanted to be able to go in with the tug tool and pull the patch down so it's right at the beginning. Now a lot of time can be spent on this part of the process in order to get a perfectly matched tangency. But we're going to get it decent for sake of time within this demo. Any little bits that are overhanging like that, we can just pull them down into the surface of the skull because we're going to do a Boolean operation in a moment. We're going to take the geometry of the skull and use it as a cutting instrument against this plug, and you'll see the result. So any noise, any little bits that are left hanging will simply be deleted in that function. And you see I'm just going around the surface of the skull and orienting the view so that it's level with my viewport, and that allows me to see if there's any bumps or valleys where the patch meets the surrounding defect. Now after we finish the tug operation, we apply it, and then we're ready to do our first Boolean operation. Boolean operation simply means that you're subtracting one volume from another. So we take the skull and subtract it from the patch. And now I'll hide the skull so that you can see what's happened to the patch. We've created a perfect juncture between the defect area and the geometry of the patch, but everywhere that hung inside the skull has created these undercuts. So we don't want to have undercuts, especially if this is going to be cast or manufactured in a traditional two-part mold. We simply don't want undercuts at all. Also, for the implant procedure in the operating room, there can't be undercuts, obviously. So we carve those away. And then we go through a smoothing operation in order to clean up the noise right along the edge there that resulted from the bullion operation. At this point, we're pretty much finished. A chamfer edge could be added to the backside, or it could be left simply as is, because at this point we have a perfect fit with the scan data from the patient. And that concludes the skull patch implant demo using FreeForm Modeling Plus version 8.2.